Right, good day, boys and girls and you colleagues. My name is Mr. Mpahama. I'm a subject advisor for mathematics. Today, of course, we are going to look at the calculus, but under calculus specifically, we're going to look at cubic functions, right? Talking about cubic functions, you'll remember that it's very important to know when we talk of the cubic functions, what is it that we are referring to? What type of the functions is that one? Remember now, you have a linear functions, you have quadratic function, exponential function, as well as what? As well as the cubic functions. Those one are very, very important. Right now, when you look at this one here, the graphs of cubic functions, what is it that is different with other graphs? I think that is very important things that you must look at today. Remember, boys and girls, you know how does quadratic functions look like. You know how does hyperbolic functions look like. It's very, very important. Right, today we're going to look at more details on the cubic functions, which of course is very, very important. Right, now the standard form here for cubic functions is ax. You can see here, hope you can see it clear. It's ax to the power of 3 plus bx squared plus cx plus d. Right, this is a standard form for the cubic functions. Of course, when you talk of the quadratic functions, you remember that here we have what? We have ax squared. The quadratic one, we have f at x is equals to ax squared plus bx plus c. Of course, if I have to write the linear one, now remember that is only what? Ax plus b, and then the exponential one is b to the power of x there. Right, boys and girls, it's very important to know when you talk of the quadratic function, when you talk of the linear, when you talk of the exponential and the hyperbolic functions, what is it that we are referring to? Please make sure that you follow, because I think the difference between these functions are only few. They are only few. Not everything that you'll find that in the quadratic functions, you also have it here in the cubic functions. Right, now let us start with the shape of the graph first. How does the shape of the graphs looks like? Of course, the shape will be determined by the value of a. You remember now here, we have what? We have f at x is equal to ax, so exponent of 3 plus bx plus cx plus d. Right, the value of a here is the one that will tell us how does the shape of the graphs looks like. Okay, right, let us look at this side here, where a is greater than 0. Then you can see that if a is greater than 0, then the shape looks exactly like this one here. It means the function will increase first, and then we have the maximum turning points, and thereafter the functions decreases and then increase. Immediately when it decrease and increase, then we'll have the minimum turning points. Now what we can say in short is that immediately if the value of a is greater than 0, of course we are going to start with the maximum turning points. Good. Now that's the first point that is very important. A greater than 0, we start with the maximum points. It means the graph increase first. Good. Now, what if a is less than 0? What if a is less than 0? Then you can see on this side, if a is less than 0, then let us look at the cubic functions shape. Now it means the functions will decrease first, right? The function will decrease first. Of course, we are going to start with the what? With the minimum turning points, which is very, very important. And thereafter, then the function increase and decrease after, which will lead us to a maximum turning points. The 2 points are very important. A less than 0, the graph decrease, then increase. Then we're going to have the minimum turning points. If the a is greater than 0, then of course the function will increase first, and then we're going to start with what? We're going to start with the maximum turning points, which is very, very important. Right, I think that is the first thing that you must look at right now. The second one now is the procedure for sketching the graph of the cubic functions. You remember we have the procedure as well when you sketch the quadratic, when you sketch the hyperbolic, as well as the exponential one. Right, now remember those three quickly. What is it that you need when you sketch the quadratic functions? What is it that you need when you sketch what? The hyperbolic as well as the exponential, so that at least you can be able to compare the two. Then to say, okay, what is difference with the cubic functions as well as the quadratic as well as the hyperbolic functions? Of course, will agree with me that first of all, what we need to determine there is the x and the y intercept. It's very important, right? The first thing that you must look at is the x and y-intercept, right? X and the y-intercept, that is the first thing that you must look at. Boys and girls, you know, when you talk of the X and the y-intercept, I always call it in our daily bread, you know, when you talk of the X, we know that y must be 0 there. And when you talk of y, then you know that X is supposed to be 0. Then you let X to be 0. Those two are very, very important. Please don't make mistakes, because you know that that point will be exactly on the x-axis, and then this one on the y-intercept, that point will be exactly on the y-axis, which is very, very important. As you can see here, like we said, finding the y-intercept, you let x to be 0, and then finding the x-intercept here, and then let f at x be 0. That f at x, it represents the y value. I think, boys and girls, you have this one clearly. Right, and then, remember now, we are talking about the cubic function here. Then we are expecting to have a cubic equation, right? Now, how do you solve the cubic equation? When you talk of the quadratic functions, now the exponent is 2. Now we're going to have a quadratic equation. You know how to solve the quadratic equation, right? Now let us see. How do we solve the cubic equations, right? First, you need to find the factors of f at x by finding the common factor. It means, first of all, what you can do, always like we say with a quadratic equation, first of all, see if you can see the common factor in that equation's name. See if you can see the common factor in that equation, and if there is a common factor, then you take the common factor out. Okay, or if there is no common factor, because you'll be having 4 terms or 3 terms, then from that one, then you can group the terms. If there are 4 terms, you can take the first 2, you group, and to see if you can take out a common factor, and then you take the last 2 as well, and then you see if there is a common factor. Then on that one also, that is another way of factorizing the cubic equations, and the other one by using a factor theorem. Of course, this is the very, very important one, using the factor theorem. You know, you'll find it developed that when you substitute in that equations, then you get 0, and now you can take it from there to factorize in details. Good. And now, it means now the first thing that you talked about is the x and the y-intercept. Now you understand what is it that you need to do, especially when you find the x-intercept, right? The next point after the x-intercept will be what? Will be the turning point. The next point there will be the turning point, right? Good. Now, here is supposed to be turning points, because we agreed that we are going to have a more than 1 point here, which is very important, right? Now, remember now, boys and girls, it's not the first time you hear the words the turning points. Is that correct? Which functions did we do the turning points on it as well? Yes, you are right. That is a quadratic functions, right? How do you determine the turning points of the quadratic functions? Yes, you use the axis of symmetry, which says that here you have x is equals to what? X is equals to minus b over 2a. Once you have x, now it means what you will do here, you just take this one and then you substitute it in the equations, then you have the corresponding y values, right? Now, let us see what's going to happen with the cubic functions. How do we determine the turning points? How do we determine the turning points? Of course, the first thing that you must look at is we must have f prime of x. We must have f prime of x. What is f prime of x? That is the derivative. Is that correct? That is the derivative, but especially at this point, I also refer it as a what? As a gradient. I also refer it as a gradient. And then once you have that derivative, you let the derivative to be 0. You let the derivative to be 0. I know one will say that, but why do you let the derivative to be 0? Of course, you remember that, like I said earlier on, if a is greater than 0, we are going to have the maximum turning points. Of course, you know the gradient of the straight line. Here the gradient is positive. Here the gradient is negative. But what is happening at this point here? What is happening at this point? The gradient is 0, right? The gradient is 0 there. That is why you must have the derivative, and then you let the derivative to be 0. Now, once you have let the derivative to be 0, and now you can do what? You can solve for x. Of course, you will have the values of x. X is equals to this and x is equals to that. There will be only 2 x values there. Right. Now, once you have the x values, what is it that you're going to do with those values? right? You substitute the x values into the original equation. It's very important. Substitute the x values into the original equations to find the y coordinates of the turning points, right? Like you did with the quadratic one. Remember, first you had x is equals to minus b over 2a. It means you managed to have the x value at the turning points. And then immediately after that, now you took that x value, then you substituted it in the original equations, now to have the y coordinates of the turning points. Right? You do exactly the same here. After you have solved the x, you'll have the value of x, and now you take the x value, and then you substitute it into the original equation to get the y coordinates of the turning points, of course, which is very, very important. Right, and then from here now, you can also state the nature of the turning point. Is this the maximum turning point or is it the minimum turning point? Of course, you'll remember if the value of a, if the value of a is greater than 0, of course, we'll need to have the maximum turning points first and then the minimum turning points thereafter. But if a is less than 0 there, you'll have the minimum turning points, and thereafter you have what? You have the maximum turning points. Of course, I think it's very, very important, really, before you can determine the nature of the turning points, just look at the value of a there. What is the coefficient of a? Is it a positive or is it negative? Right. I think, boys and girls, you are following here, and thereafter, after these two now, you can now be able to do what? You can now be able to draw a smooth curve of what? Of a cubic functions. Remember, I didn't say a smooth curve of a quadratic name, a smooth curve of a cubic functions, which is very, very important. Right now, and then of course, right after you have sketched the graph, but maybe okay, let us focus on the first three bullet first. Let us focus on the first three bullet first. Which one is that one that I'm referring to here? I'm referring to number 1, x and what? X and the y intercept, right? Very important. X and the y intercept, that is the first one. And then the second one, that is the turning points. Of course, it's very important. And of course, with these two information that we are having here, now we can be able to do what? To sketch a smooth curve, right? Now we can be able to sketch a smooth curve of a cubic functions, which is of course very, very, very important. Right. Now, let us take one example. Let us take one example before we talk of what? Before we talk of the point of inflections, as yes, how to find the point of the inflections. Right. Now we are going now to take one example here to see if really what we are talking about here, we will be able to do what? We will be able to apply. Right. Now, here is the functions here. Our functions is f at x is equals to what? F at x is equals to x squared minus 4, x to the power of 3 minus 4x squared plus 4x. Right. Now, when we look at these functions here, how many terms do we have? We have 3 terms. Most of the time, we only have 3 terms only when we have a quadratic what? Quadratic equation or quadratic functions. But what is important is you must remember when we are talking about the cubic functions, what is it that it makes these functions or this equation to be the cubic? We just look at the degree, the exponents there. If it's exponent 3, then we know that this is the cubic functions. Of course, right now. Okay, let us start with the first one. Of course, I can now start with what? I can now start with the y-intercept, right? I can now start with the y-intercept. How do we determine the y-intercept? Then we let x to be 0. We let x to be 0. This is the easiest one to start with. Nay, it's the easiest one to start with. It means everything here, wherever we see x, we substitute it by 0. That is a 0 to the power of 3 minus 4 times 0 squared plus 4 times what? Times 0. And then now you can see that the y-intercept there, it's 0. It means this graph, this function will pass through the x-axis, through the x-axis at the origin. In fact, it will touch the y at origin. Right. Now we have the y-intercept. Now, let us look at the x-intercept. Let us look at the x-intercept. Right. How do we determine the x-intercept? of course, you let y to be 0. Right, let us do that one to see what's going to happen here. Of course, that will be 0 is equals to x to the power of 3 minus 4x squared and then plus 4x. Good. Now look at this one now. We have now the cubic equation, right? You see how equations are important, boys and girls. Equations are very, very important because if you really don't understand the equations, of course, now, believe me, you're not going to be able to sketch all these functions. No, you're not going to be able to sketch all these functions. That is why it's very important to make sure that you master the equations. Good. Now here, y-intercept there, x-intercept, y is 0. Right now, we have 3 terms here. What do we do now? First thing that you must look at is what? Common factor, right? First of all, check if you have common factor. That is the first step that you must take. And then if there is no common factor, check if you can group the terms. If you are unable to group the terms, now then you can go now to what? To a factor theorem. Right. Now let us start here now. Do we have a common factor here? Yes, you are right. The common factor there is what? The common factor is x. Now we are taking x out. We are taking x out. What is it that we are left with now? We are left with what? X squared. Yes, x squared minus 4x, of course, and then plus what? Plus 4. Right. Okay, we have x squared minus 4x plus 4, and then we have x outside there. Please, boys and girls, it's very important. Make sure that immediately once you have taken out the common factor, just say x times x squared to see if you get x to the power of 3, and then x multiplied by minus 4x, it should give you minus 4x squared, and then x multiplied by positive 4, it must give you a positive 4x, right? And now from here, where do we go now? Of course, now we want to factorize this one. Let us see if we can have the factors of the brackets. Now, x squared minus 4x plus 4. What are the factors here? We start with x squared. The factors there will be x multiplied by x. Of course, that will be x squared. Now, what are the factors of 4? What are the factors of 4? Factors of 4, of course, is what? It's 1 multiplied by what? 1 multiplied by 4. That is the first one, 1 multiplied by 4. And then the other one will be what? 2 multiplied by 2. Not 4 there. 2 multiplied by 2. Of course, between these two, you must choose the one that when you add, then it gives you what? It gives you 4 because you have a plus 4 there. If it's a plus, it means it's either you have a negative times negative or you have a positive times a positive. Right now, if the same are the same, then it means you are going to add there. You are going to add those terms or those numbers, right? Okay, now, which factors must we take? 1 times 4 or 2 times 2? Of course, we cannot take 1 times 4 because immediately when you take 1 times 4, we are going to get 5 when you add the 2, right? But when you take 2 times 2, then it will give us 4. But when you take 2 plus 2, then the answer there is 4. Then it means we take a 2 there, we take a 2 there. Now the question now is, what is the sign now? Of course, it will be negative times negative, which would give us minus 4x, and negative 2 times negative 2 would give us what? A positive 4. That's good. And therefore, from here, we know that now you can say, therefore, now x is equals to 0 or x is equals to a positive 2. That's good. Now, boys and girls, now we have the x as well as what? We have the x and the y-intercept. Right. Now, what are the coordinates of this point here? Of course, you must also remember that at this point, x is 0, y is also 0. Then what about this one here? Yes, this one as well. X is 0, y is 0. What about this one here? X2, then y is 0. It means it's on the, x-axis. Right. Right, boys and girls, I think now you are happy with the first part of the x and the y-intercept. Right. Let us now go to the second one. The second one now we are referring to what? We are referring to a turning point. We are referring to the turning points, right? How do we determine the turning points of the cubic functions? No, we are not going to use x is equals to minus b over 2a. Remember here we said we must do what? We must find f prime of x. We must find the derivative of the function f, right? Now, we have f at x is equals to what? Is equals to x with the exponent of 3 there, minus 4x squared, and then plus 4x, right? And then from here, we must find the f prime of x. Do you still remember how to find the derivative? Do you still remember? Yes, you remember. If you have what? F of x there, no, f of x is equals to ax to the power of n. Now, f prime of x will then be what? F prime of x will then be, you take n multiplied by a, you have a times n, and then x, and then from that n, you just subtract 1 there. You would have something like that one. It's very important to know how to find the derivative. You know how to find the gradient, because we refer the derivative also as a what? As a gradient, especially when we deal with this one, so that at least you can understand what is it that you're talking about. Okay, right. What will be the derivative of x to the exponent of 3? Of course, we look at the coefficient. What is the coefficient there? It's 1, right? And now we say 3 times 1, that is 3. And then, of course, from the exponent to minus 1, then you're going to have 2. That is 3x squared. And now from here, what's going to happen there? 2 times minus 4, it's a minus 8, of course. And now 2 minus 1 is only a 1. And therefore, here we have what? We have a plus 4. Therefore, the derivative of f of x there is f prime of x is equals to 3x squared minus 8x plus 4. Right. Now, are you happy so far? Good. Now, what do you know about the derivative at the turning points? What do you know about the gradient at the turning points? Of course, it's very important to remember that at the turning point there, the derivative f prime of x there is equals to 0. The gradient at the turning point is equals to 0. Good. Now, then it means now we must equate the derivative to what? To 0. Then we'll have 0 is equals to 3x squared minus 8x plus 4. We'll have 3x squared minus 8x plus 4. Good. Now, what type of the equation is this one now? That is a quadratic equation name. That is a quadratic equation. Do you know how to solve the quadratic equation? Yes, of course. First of all, we look at the common factor. We look at the factors. If no factors, then we can use the quadratic formula. Right. Now, let us see now if we can have factors for this one. Let us see. Do you have the factors? Or you're still looking at the factors? Okay. Right now, let us see now. It means now we start first with the first term, and now we go to the last term there. Now, the first term is 3x squared. What are the factors of 3x squared? That will be 3x multiplied by x, right? 3x multiplied by x will give us what? Would give us a 3x squared. Good. Now, the factors of 4. You remember we said earlier on, factors of 4 is what? It's a 1 times 4. It's a 1 times 4, or 2 multiplied by 2, right? And now let's go to this one now. Between 1 times 4 and 2 times 2, which one do we take? Boys and girls, it's very important. Don't just take those factors and then put them there. Just make sure that at the end of the day, you get the middle term, because the middle term will be the one that will determine if your factors are correct or wrong. Right now, if you take 1 as well as 4, right, if you take 1 as well as 4, of course, you can multiply 3 with 1, and then what's going to happen there? You'll have 3, nay. And then 3 plus 4 is what? It's 7, nay. Then it means this one is not going to work. Even if you take 3 times 4, then it will give you 12, right? And now 12 now, because now we have a plus sign here. It means we are adding, not subtracting there. Then it means you must add whatever that you're going to get there. Right. Now, this one is out. 2 times 2 is out. Now, let us look at 2 multiplied by 2. Right. Let us look at 2 multiplied by 2. If I write 2 here and then 2 here as well, what's going to happen? 3x multiplied by 2, it's a 6x. Is that correct? Yes, 6x. And then 2 times x is what? Is 2x. Now, when I take 6x plus 2x, what is the answer? The answer there, of course, will be 8. Now, can you see the smile on me? It means now I'm happy that these factors here are 100% correct, because they are doing what? They are giving me the the middle term, which is the most important part on these equations. Of course, now, what will be the sign now? Because it's a positive here, now we must have minus as well as a negative there. Good. And therefore, now we can now say, okay, we have 3x minus 2 is equals to 0. Therefore, x is equals to what? We take 2 on the other side. It becomes positive. And then we divide by what? We divide both sides by 3. That is why we have x is equals to 2 divided by what? 2 divided by 3. Right. Of course, the other one here is what? X is equals to 2. Right. Are you happy with the x value at the turning points? Yes. How do you determine the x value at the turning points? Of course, you take f, and then from f you find the derivative, right? And now that derivative, remember, is also the gradient. Of course, you need to let the derivative to be 0, because at the turning points, gradient is what? Gradient is 0. Then you equate it to 0, you solve for x. That is why we have x is equals to 2 over 3, or x is equals to 2. Right. I think you are happy now with this part here. Please make sure that you don't forget how to determine the turning points of the cubic functions. Good. Now, and then from here, what do we do now? We must find the corresponding y value. If x is 2, what is the corresponding y value? If x is 2/3, what is the corresponding y value? Right. Let me start with 2 first. F at 2, you said we take 2, we substitute it where? In the original. Please don't substitute it at the derivative. Do not substitute the x values at the derivative. Why? Because you are going to get 0, right? You are going to get 0. Do not substitute these values at the derivative. Okay, let me show you something here. It's not acceptable, this thing that is going to happen here. Look, if we take 3 multiplied by 2, all squared minus 8 times 2, and then plus 4. That will be what? That is 4. 4 times 3, I think, is 12. And then 8 times 2 is the minus 16 there. And then plus 4. 4 plus 12, 16. 16 minus 16 is 0. You see now. Please do not substitute your x values at the gradient, at the derivative. It's very, very important. Right? Good. Now, where do you supposed to substitute this one here? At the original functions there, f at x, right? The one of the x to the power of 3. Right, now let us substitute that one here. Now it means you are going to have what? We are going to have 2 to the exponent of 3 minus 4 times 2 squared, and then plus 4 multiplied by 2. Right, this one here is going to be 8, and this one here is 4. 4 times 4, that will be 16, and then plus what? Plus 8. Good. And then 8 plus 8 is 16, and then 16 minus 16 is 0. Now, one will say, yes, that look at this one, you're also getting 0. You said you're not. Yes, here you are going to get 0. Because when you go back to your x and the y intercept, remember, one of the x values there, one of the x intercept is what? It's x is equals to 2. It means 2. It's the x value at the turning points, and it's also what? It is also the x-intercept of the functions. That is why we are having 0 there. I think you understood this one, right? Okay, good. Now let us look at the second one there. F at what? F at 2 divided by 3 there is equals to what? Is equals to, we are going to have what? 2 divided by 3 to the exponent of 3 minus 4 multiplied by 2 divided by 3 there squared, and then plus 4 multiplied by 2 divided by 3. Right. Of course, we can work this one out. That will be what? That will be, of course, 8 divided by 27 minus, this is going to be 4, right? And then 4 times 4 minus 16 divided by 9. And of course, this is going to be plus what? This is going to be plus 8 divided by what? Divide by 3. Right. We can quickly also work it out on the calculator to see what is it that we're going to get there. And now we have 2. Let me put everything in. We have 2 divided by 3, all to the exponent of 3. And now minus 4 multiplied by 2 divided by 3, all squared. And now plus 4 multiply by 2 divide by 3, right? And then this one we just multiply because it's the exponent of 1. Of course, at the end of the day, we are going to get what? We are going to get a 32 divided by a 27. Right. Now, the question now will be, what are the coordinates of the turning points? What are the coordinates of the turning points? Of course, the first one that we have here, x is what? X is 2, y 0. Right? That is the turning point that we have. And the other one here on this side, x is what? X is 2 divided by 3 there. And of course, and then the y will be what? Y will be 32 divided by 27. Right. We can also write it in the decimal form because at the end of the day, you are going to use that one in decimal form. Decimal form, then you're going to have what? Decimal form, we're going to have this side here is going to be 1 comma what? 1 comma 1 9 or 1 comma 2, and then 2 to divide by 3, then it's going to give us what? 0 comma 6, right? It's going to give us 0 comma 7, right? These are the coordinates of the turning points. Good. Now we have the x and the y-intercept. We have the turning points. So remember, how did we find the turning points? Yes, it's very, very, very important. Good. Now, what do you think will be the next question from here? Yes, we need to sketch you need to sketch the functions, right? Of course, boys and girls, remember now, when you look at the value of a here, a is positive, right? A is positive. It means the function will increase first and decrease after. Then it means you're going to have the maximum turning points and then minimum turning points. Between the two now, which one is the maximum, which one is the minimum? Of course, yes. This one will represent the maximum, and this one will represent the minimum, right? The other one will represent the minimum. Good. Now, let us sketch the graph to see what is it that is going to happen when you sketch this function here. Okay, right. We will have this one here. We will have the y-axis as well as the x-axis, right? And then we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right. And now from here, that is 1, 2, 3, 5, 6, 7. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5, 6. Of course, you know that when you go to the right, x are positive, and then when you go to the left, they are negative. The same apply up, y they are positive, down, below the x-axis, then negative. Right. Now we must put in the information now. We can start with the y-intercept. What are the coordinates of the y-intercept? Yes, we said this what? We said 0 there, 0, 0. Then you indicate there. Yes, our y-intercept there. Then it means the graph will go through there. Will go through the origin. Right? Good. Now, what about the x? Yes, 0, 0 first. That's the origin as well. And then the other one will be, the other one is 2 and 0. These are the coordinates of the x-intercept. Good. Now, from the x and the y-intercept, where do we go now? We now go to the turning points. Is that correct? Good. What are the coordinates of the turning points? We have 2. We have 2 and 0, right? We have 2 and 0. Of course, it's this one here. That will be the turning point. Is that correct? Now, the question now, I always say, it's very important that we indicate the turning points as early as possible, right? Of course, maybe if we can go to this one before we do whatever that I wanted to tell you. That is 0, 7. Where is 0, 7? 0, 7 is somewhere here, right? And now, if x is 0, 7, then what is y? Then y is what? Y is 1, 2. Y is 1, 2. Then y, 2, then it will be somewhere here. That is 1, 2. Of course, now, once you have something like this one, it's very important to indicate, okay, this is a turning point. The graph cannot go up. It needs to turn here. Is that correct? And you also indicate this one as well. then this must be a turning point as well. Is that correct? Good. And now from here, look, your life is easier now. The only thing that you need to do is just to join this one. It must go through what? It must go through the origin. And now you join this one as well. And now then you take this one up. And now you have the cubic functions. Look, your function increase first, and now decrease and increase. Can you see that one? Yes, it's very, very important. What are the coordinates of the turning points? 2, 0 there. And what about this one on this side? That is 0, 7 as well as 1, 2. Right. Are you happy now with the function? Right. Can we quickly look at those things that we looked at before we sketch these functions? Yes. What are those? That is the x and the y-intercept. The turning points. How do you determine the turning points? Of course, when you determine the turning points, you need to have the derivative, and now after the derivative, you let the derivative to be 0, and now you have the x value, and then from that x value, then you take them, then you substitute them where? In the original to find the corresponding y value. Right, are you happy now? Yes, I can see the smile. Of course, I can see the smile. Good. Now, from this one now, let us quickly now look at the last part that I said to look at it later on after we have sketched the smooth curve of the cubic functions. The last part is how do we determine the point of inflections? It's very important. Now, how do we determine a point of inflection? Right. Here, when you determine the point of inflection, you need to have f second prime x. You need to have the second derivative. You need to determine the second derivative. It means now you will take your first derivative and then find another derivative. That is equally, that is a second derivative. And you must also remember to let the second derivative to be 0. It's very important. You let the second derivative to be 0, and therefore you solve for x. Right. And also remember now, when you find the derivative, remember here at the derivative we had a quadratic function name. We have a quadratic function, right? From this one, you can see you have 3 terms there. One can also decide to use what? X is equals to minus b over 2a, right? Why this one? Remember now, this is the x value at the turning point. Also the axis of what? Also the axis of symmetry. Right, this is the second one that you can also use when you determine the x value at the turning point. Right, and also, boys and girls, look, and when you have the x value at the turning point, right, you can also use those values here. You can also take x1 and x2, then you divide the 2. They will give you the x value of the point of the inflection, right? Use the x coordinate at the turning point or the x-intercept of the parabola, because sometimes when they give you the parabola in this case, then you know that is the derivative. Right, to find the corresponding y value, of course, is still the same case. Right, once you have the x value, then you can substitute the x value into the original equation to find the y value. I think, boys and girls, is now clear. I think now it's very, very clear, this one. Right, now, okay, let us find the point of inflections of these functions that we have here. Let us find a point of inflection. Let us find a point of inflection. Right, remember, the functions is f of x is equals to x to the exponent of 3 minus 4x squared and then plus 4x, right? And now you said that the derivative f prime of x there is equals to 3x squared minus 8x, right? And then plus 4. Right. Can I give you just 2 minutes, boys and girls, just to find the second derivative for me? Just find the second derivative for me. Now we have f prime of x there is equals to 3x squared minus 8x plus 4. Now, what will be what? What will be the second derivative? Thank you. Right. Boys and girls, now, what is your answer? What is your answer on this one? What is the second derivative if we have f prime of x is equals to 3x squared minus 8x plus 4? Of course, we are going to have what? You remember how to find the derivative? 2 times 3. That will be what? That will be a 6x, of course. That is a 6x. and then you have minus what? Minus 8. Is that correct? Because that is 1 times negative 8 is a negative x. 1 minus 1 there. That is x to the power of 0. X to the power of 0 is 1. Now, what is the derivative of 4? The derivative of 4 then would be 0. And of course, the other thing which is very important, you must let what? You must let f second prime of x be what? Be 0. Then we have 6x minus 8 there is equals to 0. And now then from this one you can say 6x is equals to 8. When you move it to other side, it's going to be positive 8. Then divide by 6, then x there. What is 8? Then of course one can say this one is going to be 4, and then this one will be 3, right? Yeah, one can say 2 into 8 goes 4 times, and then 2 into 6 goes how many times? 3 times. That is why now we have x is 4 divided by 3. Right? Of course, boys and girls, these questions, remember, they can ask you in 2 ways, right? They can ask you to determine the x value at the point of inflections. Now, if they ask you to determine the x value at the point of inflections, this is what you must do. Just going to stop here. This is the x value there. This is the x value there at the point of the inflections, right? Of course, if they ask you to determine the point of inflection, then it means they're expecting you to have the x and the y. Right, now, from here, once you have the x, what do you do now? You take the x, which is 4 divided by 3 there, then you substitute it there in the equation, then you're going to have 4 divided by 3 to the power of 3 there, minus 4, then 4 divided by 3 squared, and then plus 4 there, 4 divided by 3. Now you say equal sign there. Now we can use the calculator to work this one out. Then we are going to have brackets there. That is 4 divided by 3 to the exponent of 3 minus 8 bracket 4 divided by 3 there. This is going to give us what? That is squared, and then plus 4, and then 4 divided by 3. Good, and then the answer there is going to be, let me see this one right. That is minus 4, not minus 8. That is minus 4 there. That is minus 4, right. The answer there is going to be 16. It's going to be 16 divided by 27. Right, now, in decimal, then this is the same as 0.59 or 0.6. Right, now the coordinates of the point of inflection, that will be 4 divided by 3 as well as 16 divided by 27. Right, now when you look at our function now, let us see where is this one. Where is the point? Now, of course, 4 divided by 3, then we have what? 4 divided by 3. It says that is 1,33. X there will be 1,33. That is x somewhere here, 1,33. And now you said y. Y will then be what? 0,5, which is 0,6. 0,6, I think the point will then be here. You can see now these points divide these two graphs. Okay, right. This is the x-intercept and the y values of the point of the, that is the x value and the y value of the point of the inflections. Right. We also said that you can also use x is equals to minus b over 2a. Okay. You can also use x is equals to minus b over 2a. Right. What is it that you're going to do here? In this case, you just focus on this one to say, okay, fine. Let me see. Now, the b here is a minus 8. Then you have minus. Now, minus 8, I divide it by 2, multiply by 3. Right? This is going to be positive 8 divided by what? Divided by 6. You remember, that's what we had earlier on, 8 divided by 6. When you simplify this one, that is 4 there, divided by 3. Right, that is the first one. The second one, we said you can just take x, that will be x1 plus x2 divided by 2. Of course, x1 at the turning point there. Remember, we did round it off to the nearest. Let me see what was the value there at that time. That is 2. That is 2 divided by 3 there. And then plus what? Plus 2. Then I divided this by 2. Right, when we add this one, 2 divide by 3, good, and then plus 2. Then we divide this by 2 as well. We have what? Exactly the same answer, 4 divided by 3. Good. Right. Boys and girls, good. I think you have this one here. Let us quickly look at this, at what we did from the beginning of this session here. Right. Of course, we've looked at features of cubic functions, right? We said when you sketch the cubic functions, you need to look at the x and the y-intercept, which is very important. Y-intercept is a straightforward one, but x-intercept, you need to factorize the cubic equations. How do you factorize the cubic equations? Of course, you need to look for common factor. If there's no common factor, you group the terms because you'll be having 4 terms, right? Now, then if you can't work with the one of grouping, then you use the factor theorem, right? And now from that one, we went to the turning points, right? How do we determine the turning point? We said we find the derivative, and now you let the derivative to be what? To be 0. Then you solve for x, and now immediately once you have the x values, now you take those x values, you substitute them where? In the original equation, so that we can have what? You can have the corresponding y value. Right. With that information, of course, now x and the y-intercept as well as the turning points, now you will be able to do what? You will be able to sketch a smooth curve, right, of a cubic functions, right? Hey, boys and girls, we are going to take a break now. During your break, just try to remind yourself these things because they are very important, and then look how different this cubic function it is with the quadratic functions, with hyperbolic functions, as well as the linear equations. They are very, very important if you can be able to differentiate between the three. Right. I will see you after the break, and then now I think we'll look at 2 or 3 examples of the cubic functions. Right, thank you, boys and girls. Thank you very much. I think you did that during the break. You have looked at the difference between the quadratic functions, hyperbolic functions, exponential, linear, as well as the cubic. You would see that in all these functions that you have mentioned here, x and the y-intercept is there. And then the other one, the 2, especially quadratic as well as the cubic functions, you have the turning points. But when we get to hyperbolic functions, you don't have the turning points, but what is it that you are having there? You have what there? The asymptotes, right? Which is very, very important. Good. The same applies to the exponential. You also have the asymptotes, and thereafter now we can be able to sketch the graph. Right, now, we had a question here, right? If the function is given as a quadratic name, is it possible for us to take that function back to the cubic functions? Right. Now, basically, it's very important to this part here. Right. I'm going to take these examples to try to respond to the question. I hope that at the end of this, you'll understand really what is it that we are referring to. Right. Let us look at this one here. We are saying now in the diagram below, the graph of y is equals to f prime of x is represented. In the diagram below, we are referring to this one here. The graph of y is equals to f prime of x is represented where f at x is equals to ax above 3 plus bx plus cx represent a cubic functions. Now, what is important is now immediately you can see that we don't have the value of d here, which is very, very important, right? Now we have only 3 terms. That's good. Okay, and now from here they will say now determine the equation of f prime of x and then f of x, where f of x is equal to ax above 3 plus bx squared plus cx. Right, it's exactly the same with what we have started on earlier on, right? Boys and girls, this one we need to find the equation and everything. We'll get back to that one, right? Let us quickly look at this one here. The derivative of the function, here was f prime of x. It's very important to know that immediately when you have a quadratic functions, you must know that one represented the derivative, right? It was what? It was 3x squared minus what? Minus 8x, and then we have plus 4. Right. This was the derivative of the quadratic function that we have after we have the derivative. Right. Now, you want us to take this back to what? To f at x. Is that correct? Yes, it's very important, right? But you must remember that f at x is equals to ax to the power of 3 plus what? Plus bx squared plus what? Plus cx. It's very important. F prime of x is equals to 3x squared minus 8x plus 4. And then f at x is equals to ax to the power of 3 plus bx squared plus cx. Now, what is important now, we need to determine the value of a, b, as well as c, or to find the cubic functions. Good. Now, what is it that we must do? I think the first step, because here we have everything here, the first thing that we need to do here is to have the derivative of this one here. We say, okay, f prime of x here will be what? Will be 3ax squared. Great? Yeah, that will be 3ax squared plus what? Plus 2bx. Name. Plus 2bx, that's great. And now plus what? Plus c. Good? Now, we have the derivative of f, which is 3ax squared plus 2bx plus c, which is very, very good. Right. From here, where do we go now? This is the derivative. This is the derivative of f. Right. Now, what do we know is this 3a is equals to positive 3. Right. Now, you can say, okay, 3a is equals to 3. This 3 that we are having here is the derivative of ax squared, ax to the power of 3. Then it's equals to this 3 that we are having. Just equate to the 2. And now you divide by 3. Then the value of a then will be a positive 1. Good. And now you go to the second one. Right. 2b. Right. 2b is equals to what? 2b is equals to a minus 8. Right, and then from here, you divide by 2. And therefore, now b is equals to what? Negative 8 divided by 2, that will be a negative 4. Is that correct? Yes. Of course, the last one then will be c. Now, c here is equals to what? C is equals to a positive 4. Right, what will be the equation of f? Now, I can say, therefore, f of x, f at x is equals to a is 1, that is x to the power of 3. That's correct. And now b is minus 4. That is a minus 4x squared. And now c is 4. That will be a positive 4x. Now we have the cubic functions. You remember at the beginning, it's exactly still the same. We have f of x is equals to x to the power of 3. X to the power of 3 minus 4x squared plus 4. And then plus 4. It's very important. If the functions is given here as a quadratic, remember that is the derivative. Immediately when you see the quadratic in a cubic functions, then you remember that is the derivative, right? And now, if you have this one, you need to find the derivative, and now you can equate the 2, and now you equate the 2. That is why now we have a is equals to 1, b is equals to minus 4, and then c is equals to 4. Right? I think you are happy now with the way I have responded to your questions. Boys and girls, please don't be afraid to ask questions. If you feel that you need clarity on something, then you can ask the question, then we'll get the answer now. Right, let us get back now to our daily work now. We are still busy with what? We are still busy with the cubic function. Is that correct? Yes, good. Now, let us take this one now. I want us to look at the first 3 questions. For me, they are very, very important. The first 3 questions, they are very, very important for me. Good. Now, why do I say very important for me? Because look, really, if I do well in this one, can I see now I have almost 13 marks? Yo, that will be great. That will be great. Boys and girls, no matter how difficult the question is, the first thing that you must remember for all the functions, you must know how to sketch them. That will be the bonus for you. Right, now, boys and girls, now this one we're going to do it together, right? They're saying here, given that f at x is equals to x to the power of 3 plus x squared minus 5x plus 3. Is that correct? Yes. That is f at x is equals to x to the power of 3 plus x squared minus 5x plus 3. Good. Now, the first question says, determine all the intercepts of f at x. Determine all the intercept. It means now determining the x and the y intercept of f. Now we are looking for the x and the y intercept of f. Right, boys and girls, what I'm going to do, we are going to get 3 minutes to find the x and the y intercept, and then immediately we discuss specifically the x and the y intercept. You know, when I talk of the x, something is coming in your mind, and also when I talk of the y, you also remember something. Good. Now, in 3 minutes' time, we are going to discuss 3.1, all the intercepts of f. Right, thank you very much. Let us see what is it that you are having here. Y-intercept as well as the x-intercept. Like I said, the y-intercept is easier to find. The y-intercept is easier to find because we know that we must let x to be what? Let x to be 0, right? And now, from these functions here, remember f at x, g at x, each of it represent the y. Now we have y is equals to, that will be 0 here, that will be 0, that will be 0. Then it means the y there will be a positive 3. That is the y-intercept of the functions. Is that correct? Good. Now we must look for the x-intercept, right? We must look for the x-intercept. Must look for the x-intercept on the other side. What do you know with regard to the x-intercept? I know that y is supposed to be what? Y is supposed to be 0. Of course, here we have 0 is equals to x to the exponent of 3 plus x squared minus 5x plus 3. Right, that's what you have here. Now, can you see now you have a cubic equation now? Yeah, now you have a cubic equation because one side now is 0. You still remember the standard form, which is very important. The exponents must be in a descending order. Right, now, what do we do from here? You know we must factorize this one. One of these factor would be the linear, and the other one will be the quadratic. Is that correct? Yes, this is 100% correct. Good. Now, you remember that I said earlier on, when you factorize, when you solve the cubic functions, we take out a common factor. If no common factor, you try to group the terms. If you can't group the terms, now you lose a factor theorem. Is that correct? Yes, boys and girls. You know, when you use the factor theorem, you'll be taking these values from -3 to +3. And now you substitute them here. The one that will give you a 0, now you say that one is a factor. Is that correct? Yes, that is 100% correct. But you know, sometimes taking the values one by one, substituting them, they will take too much time. Of course, now we'll try to work it out here on the calculator so that at least we have that one quickly instead of substituting them 1, 1, 1. Okay, first of all, I need to have this function here. That is x to the exponent of 3 there. And then I have plus, of course, x squared there, minus 5 there, alpha x, and then plus 3. I have now this function here. Now equal sign. Of course, I'm not looking for the second one. Now, it says you start with what? I want to start from -3. I want to substitute all these values from -3, which is good. And now, I can also go to a +3 as well. It's still fine with me. Good. Now, look at this one. The steps are the multiples, right? Now, 1, 2, 3, 4, 5. Of course, I want to use the multiples of 1. Then that will be great, right? Now, look at this one now. The values of x is a -3, -2, -1. Now, if I substitute -3 here, what will happen? Then I get 0. If I substitute -3 here, I get 0. The y value there is what? It's 0. Then it means what? It means x plus 3 is a what? It's a factor. Is that correct? Yes, if you get 0 on this side of y, then it shows that when you substitute -3, then you give 0. Therefore, x plus 3 will be a factor. That's great. Let me see if there is another one as well. Yes, there is another one here. The other one is when x is 1, then y is also what? Y is also a 0. That will be great. Of course, I have only 2. I have only 2. Right. Boys and girls, we have what? We have x is equals to -3. When we substitute -3 there, we get 0. And also when we substitute 1 there, we also get what? We also get 0. Good. Now, it means we can take one of the two. If we have something like this one, we know that x plus 3 here is a factor, so that for us, when we substitute that negative 3, we get 0. Or also here, x what? X minus 1, also a factor. So when you substitute positive 1 there, we get 0. Good. Now I can now say, okay, x plus 1, it's a factor. Is that correct? Good. And now, this side, now we are looking for the quadratic one. Is that correct? Yes, the quadratic one, of course, it must be what? It must be ax squared plus bx plus c. Boys and girls, there are many ways to solve this problem here. Many ways. One can decide to do what? One can decide to use the long division method. Of course, it is still correct. One can use, there are many, many ways to solve this problem, right? But at the end of the day, make sure that whatever you are using, you understand it. Make sure that whatever you are using, you understand it, right? Of course, I'll try to save time as well. The one that I'm going to use on this side, of course, I think it will save our time as well, when we solve this one here. Right, boys and girls, I would start on this way, right? Of course, to say this one here, it is my factor name. What is the factor there? It should be 3. Yes, it should be positive 3 there. The factor there is a minus 3. Is that correct? And thereafter, what is it that is going to happen? Then I write all the coefficient name, or the coefficient of this function here. They must be 4. Sometimes you'll find that we have 3. Then you must make them to be 4. How? We will see later on. Right, the coefficient of the x to the power of 3 there, coefficient of x to the power of 3 there is 1, and then coefficient of x squared there is also 1, and then the coefficient of this x is a minus 5, and the coefficient here is what? Is 3. Is that correct? Yes, that's 100% correct. And now from here, we know that when you substitute negative 3 here, what do we get? When you substitute negative 3 here, we get what? We get 0. When you substitute negative 3, we get 0. And from here, boys and girls, what I'm going to do, I'm just going to add this one. 1 plus 0 there is 1. Is that correct? Yes. And now I take minus 3 times 1. It gives me minus 3. Yeah, it gives me minus 3. Of course, and then I take 1 minus 3. It will give me what? A minus 2. Yeah, it will give me minus 2. And then, of course, now I see minus 2 multiplied by minus 3, it will give me a positive 6. That's great. And now from this one here, we see minus 5 plus 6, it will give me what? A positive 1. Good. And now minus 3 multiplied by a positive 1, of course, it's a minus 3. 3 minus 3, that is 0. Right. Boys and girls, if you can have a 0 here and 0 there, then you know that you have it correct, especially the last one here. Of course, this one we know is just to indicate that minus 3 is a factor, and this one also. If you don't get 0 here, then you must know that something is not correct. Now, then I can say, okay, A is equals to 1, B is equals to minus 1, and also C is equals to a positive 1. Then I can write this on this side to say, good, now we have now x plus 3 here, and this one we have x squared because A is 1. And now from there, B also is a minus 2x. And now C is a positive 1. And then, of course, here we have the quadratic one. Right, boys and girls, like I said earlier on, there are, of course, many ways. There are many ways. One can also say, of course, remember now we have x plus 3 here. And also we have the bigger brackets there is equals to 0. Is that correct? And now we say, our equations there is 0 is equals to x to the power of 3 plus x squared and then minus 5x and then plus 3. Right, now we say, okay, we need to say x multiplied by what would give us that? That here should be x squared because x multiplied by x squared will be x to the exponent of 3. And of course, we need to get 3 when you multiply 3 by something here. That value there will be a positive 1. So that positive 3 multiplied by positive 1 can give us the positive 3. Now the challenge will then be the bx, right? The challenge will be the bx. Like I said, boys and girls, right, you only decide to say, okay, I know that when I take x multiplied by 1, it will give me x. And also when I take x multiplied by what? When I take 3 multiplied by bx, it will give me 3bx. Good, I took this one multiplied by this one and this one multiplied by this one. Right, now look at this one, it's x plus 3bx, right? this one, it must give us minus 5x. Good. When I add this one or minus this one, they must give me what? Minus 5x. Now, because the variable there, the exponent there is 1. Good. And now from here, what is this one here? It's a 1 plus 3b is equals to minus 5. Good. And now I can take 1 on the other side. Then I have 3b is equals to minus 5 minus 1. Good. And now minus 5 minus 1 is, it's a minus 6. That is 3b. I divide by 3, I divide by 3. Therefore, b there is a minus 2. That's great. Look exactly. We still have what? We still have a minus 2. Like I said, boys and girls, please make sure that whatever method that you are using, you understand that you must also try to save time. Because remember, the paper that we are writing is for 3 hours, right? Of course, sometimes you always complain that 3 hours is not enough. Yeah, but try to make sure that you accommodate that one so that by the end of that 3 hours, you have responded almost to all questions. Good. And now we have 0 here. And now 0 is equals to, we still have x plus 3. Now we must try to factorize this 1. That is x multiplied by x. That's great. Factors of 1 is 1 multiplied by 1. Of course, both of them must be negative because negative times negative will be positive. And now, therefore, now we can say x is equals to minus 3 or x is equals to 1. X is equals to 1. Good. Right. Boys and girls, I think now we can move to the next part now. This is the y-intercept and also these are your x-intercept. Are you happy now? Yes, I can see the smile now. Good. And now, the second question here now is what? We must determine what? The turning points. Determine the coordinates of the turning points, right? I must determine the coordinates of the turning. Determine the coordinates of the turning points there. Then also on this one, boys and girls, I'm going to give you 3 minutes to go through this one quickly. And then after that, we are going to discuss it. Right, thank you, boys and girls. I believe that you are done. I believe that we have the coordinates of the turning points as requested here. Let us look at this, at what you have. You can just share it with your friends next to you there to check if you did the same thing before I go through with you on this part here. Right, do you have the same answers? Now, if the answers are not the same, of course, don't worry. I'm going to explain everything. Now, make sure that you practice. The only thing that will make you to understand mathematics through practice. Practice and practice. Thank you very much. Right. Let us look at the coordinates of the turning points. Now, the question that you must ask yourself, especially when you determine the coordinates of the turning points, is how do I determine the coordinates of the turning points of the cubic functions? Remember now, it's different from what? It's different from the quadratic function. You still remember how to determine the turning points of quadratic functions? Yes. No, I can see that you still remember that one because it's just x is equals to minus b over 2a. That's great. But now, what about the turning points of the cubic function? What about the turning points of the cubic functions? Yes, you need to determine the derivative, right? Now, you can see here, f at x is equals to x to the exponent of 3 plus x squared minus 5x plus 3. Is that correct? Yes. And now from here, we determine what? F prime of x. Remember, that is the derivative. Remember, it's a gradient. It's very important. Derivative, gradient. Good. Now, what is the derivative of x to the exponent of 3? That is what? 3x squared. Good. That is 3x squared. Good. And now we go plus. What is the derivative of x squared here? That is 2x. Yes, that is 2x. You are 100% correct. And now we go to this one here. What is the derivative of minus 5x? The derivative of minus 5x is then what? It's a minus 5. Why minus 5? You know that you take 1 multiply minus 5. That will be minus 5. And now you say x here. From this exponent 1, you subtract 1. Now that will be 1 minus 1 is 0. And then x to the power of 0 is equals to what? It's equals to 1. 1 times minus 5. That is a minus 5. And then what is the derivative of a positive 3? That is 0, right? The derivative of a constant number there is, it's 0. Good. Now we have f prime of x. We have the quadratic now. When do we get the quadratic? When we have the derivative. It's very, very important. We have the quadratic if we have the derivative. You must remember this one, which is the gradient. Right. What do you know about the derivative at the turning point? Is equals to 0. Then we must let f prime of x to be what? To be 0. At the turning points, we know that the derivative is equals to 0. Now we have 0 here is equals to what? 3x squared plus 2x minus 5. Is that great? Good. And now from here you say 0 is equals to, we open the brackets, and now we say, okay, what are the factors of 3x squared? That will be 3x multiplied by what? Multiplied by x. Yes, that's where we must start. Right. We have minus 5 here. Boys and girls, once you have a minus 5, we know that we only have a negative when we take a negative multiplied by positive, or you take positive multiplied by negative. No, don't say negative times negative, it's a positive. This one here will give you the negative, right? Then it means because this one here is a negative, then we're going to have plus and minus or plus. We're going to have minus plus or plus minus. Is that correct? Yes, good. But before we go to the signs, let us look at the factors of 5. What are the factors of 5? It's only 1 multiplied by what? It's only 1 multiplied by 5. That's good. Right. It means now, if I put 5 on this side, that will be 3 multiplied by 5. And then what is 3 multiplied by 5? 3 multiplied by 5 will give me what? A 15. Right. Immediately when I talk of the different signs, I know that I'm going to subtract them. Now, then if I subtract 1 from 15, then of course, I'm not going to get what? I'm not going to get 2. Then that is why then I would say this one will be 1. 3 times 1 is a 3. And now, then 5. 5 minus 3, that is 2. Then of course, I will be getting the answer that I'm looking for. Good. Now, the problem now will be the sign. Now, this one here, because it will be positive, and this one here is going to be negative, because we are going to have 5x, and then we have minus 3x. Now, 5x minus 3x will give me what? Will give me 2x. Boys and girls, so don't just write there and then to say, of course, I have these 2 brackets and then I filled in. We're not going to mark the work that we have written there. We just want to make sure that whatever that we have written down, it's very, very correct. And now, from that one, each and every time, you check if what you did is 100% correct. Good. Now you have the factors. From these factors now, what is it that you're going to do then? We can now say, therefore, there, x is equals to minus 5 divided by 3, or x is equals to a positive 1. Do you have these x values? Okay, great. Now, let us see now. Once you have the x values, what is it that you must do now? You must find the corresponding y values. Is that correct? Yes. How do we determine the corresponding y values? We take x, we substitute it where? In our original function there. Right. Now it means you are going to have what? F at what? F at minus 5 divided by 3 is equals to what? Minus 5 divided by 3 what? To the power of 3 plus minus 5 divided by 3 squared minus 5, and then we have minus 5 divided by 3, and then we have plus 3. Okay. And then of course, boys and girls, because I'm trying to save time, now I'm going to take this one to say, okay, that will be minus 5 divided by 3 here to the exponent of 3 plus, of course, we also have minus 5 divided by 3 squared, and then we have minus 5 times minus 5 divided by 3, of course, and then plus 3, no, plus 3, and then we have what? We have 256. We have 256 there, divided by 27. Right, when you write this one in decimal form, then we are going to have 9,5. Good. Now in coordinate form, because they said you must determine the coordinates, then x is what? X is a minus 5 divided by 3, and then y will be 256, divided by 27. Right. These are the first one. Right. The second one, of course, we take f, wherever we see x, we substitute it by 1. And now we are going to have what? Now we are going to have 1 to the exponent of 3 plus 1 squared minus 5 times 1, and then plus 3. That is 1 plus 1 is 2, plus 3 is 5. 5 minus 5 is 0. Then the coordinates there will be 1 is to 0. Look, now here I also have 0. Now immediately once I have 0, it also tells me that this 1 is also the x-intercept, right? And now, boys and girls, the other thing that you must learn is if a point is the x value at the turning points, is that correct? If it's a point, it's the x value at the turning points and also the x-intercept. That point repeats itself. When you do the factorization, you'll most of the time find that that point repeats itself. It's the x minus 1 and x minus 1. Okay, good. Now, can we now move to the next one? You still know how to determine the coordinates of the turning points? I think now you are comfortable with this one here. Right, now, from here now, what I want you to do now is the next question, which is question number 3 here, which says now, draw a sketch of f. Draw a sketch of f. What is a sketch of f? Now, you know, before you sketch the graph, you need to have the x and the y-intercept. If you did that one, you also have the turning points. Now you can be able to sketch the graph. Of course, for these functions, because we have everything, I'll also give you 3 minutes. Then after 3 minutes, then you will show me your answer there. I know how I will see that answer, but of course, you must show me your answer so that at least I can see if you are right or wrong. After 3 minutes, then we'll come back to this one. Right, thank you, boys and girls. Yes, there are a number of questions that are still coming through, which is good. Boys and girls, remember I said earlier on, if you really need to ask something, you're not sure about something, please, you can ask that one. Of course, I will respond to your question immediately after we have sketched this graph here. Good. Now, boys and girls, when you sketch the cubic functions, you remember we need the x and the y-intercept, and we need the turning points as well. Remember the value of a name. The value of a also very important. Why very important? Because it will show us if we have the minimum turning points first or the maximum turning points first, which is very, very important. Right. Let us look at this one quickly here. I would say this one is 1, 2, 3, 4, 5. And then minus 1, minus 2, minus 3, minus 4, minus 5. Good. And now we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And now from here, that is minus 1, minus 2, minus 3, minus 4, minus 5. This is the y-axis, and this is the x-axis. Good. Now, let us go back now. What was the y-intercept here? It was positive 3. Y-intercept was positive 3. Then we indicated the y-intercept, y-axis 0. That is a positive 3. Now, x-intercept, we have what? We have minus 3. That is a minus 3. Y is 0 here at this point, as well as positive 1. Also here at this point, y is also what? Y is also at 0. Good. Now we are done with the x and the y-intercept. Is that correct? And I can see that you did the same thing. You started with the x as well as the y-intercept. Good. Now let us now go to the turning points. Let us now go to the turning points. Right. And then minus 5 divided by 3 here. Minus 5 divided by 3 here will give us negative 1,7, right? Negative 1,7, yes, negative 1,7, it will be somewhere here. But boys and girls, remember, negative 1,7 is a point with what? With a positive 9,5. Now it means now we must look for 9 and 9,5. We say yes, 9,5. No, it's close to 1. Yes, 9,5 there. Okay. Right, the coordinates of this point here, of course, it must be what? It must be negative 1,7 as well as 9,5. But once I know that if the coordinates of A, no, if the value of A is greater than 0 there, then I know that this point as well, it must be the maximum. It means the functions will start doing what? Increasing first. Now, the function will increase first and then decrease after. Right? We start first with the maximum turning points. Great. Of course, the second turning point is 1 and 0. There, of course, that is the turning points here. And I can just also indicate so that at least I try to make my work very easier when I go and sketch this graph. Now, what is next now is just to join this one. I know this one must go and pass through what? Negative 3 on that side. And now it's 10. And then from this part here, where do we go? We go to the y, we go to the y-intercept, and now we join this one now. We see we have a very smooth curve now of a cubic function. Can you see this one? Yes, it's very important here. Right, like I said, the function increasing, it means the gradient of the straight line is positive, decreasing, gradient negative, increasing, then gradient positive, negative. Good. Now, boys and girls, I think you have the same shape as mine, and the smooth one, you can see mine is very, very smooth. It's very nice. Now, I didn't use the ruler to do this curve here. Right, thank you, boys and girls. Now, before we go to the point of inflection, which of course is very important, boys and girls, now let us respond to these questions quickly. The question here said, please help us to determine the value of x if the gradient of the tangent to g of x. Now, we must find the value of x. We find the value of x. Now, if the gradient of the tangent to the function gx is equals to minus x squared and then plus 2x minus 1 is 10, right? If the gradient of the tangent to the graph is 10, right? Now, like I said, what's important is you must understand, when you talk of the gradient, what is it that we are referring to? We are referring to the derivative. Of course, the function is given. We don't have the value of x. You remember now, even though we didn't look at the tangent today, that when you determine the gradient of the tangent line, what is it that you need to do? You need to determine what? You need to determine the gradient first, the derivative first, and thereafter, after the derivative, what do you do? Now, you'll be given the specific value of x that will substitute in the derivative so that you know that you are defining the derivative at that point, right? Now, what I would say from here, we know that g prime of x is equals to 10. We don't know what is the value of x that will make the gradient of the tangent to be what? To be 10. Now, what is it that we are looking for? We are looking for the value of x. Is that correct? Good. Now, it means what we are going to do, we must find the derivative of these functions here. We say, okay, g prime of x is equals to, this is going to be minus 2x squared, which is great, plus what? Plus 2. Is that correct? Because this is a 1 here. Then 1 times 2 is 2. Now, what is the derivative of minus 1? That is 0. Good. Now, we have g prime of x is equals to minus 2x squared plus 2. Right. What is it that we know? We know that the gradient of the tangent, we know that the gradient of the tangent is what? Is a positive 10. The gradient of the tangent is a positive 10. Now, this is the gradient at any point. But at that specific value, the gradient is 10. Now we want that specific value of x that will make the gradient to be 10. Right? How are you going to solve this one? We are just going to equate the two to say minus 2x, minus 2 not squared here, that is minus 2x plus 2. That will be minus 2x plus 2 is equals to 10. Is that correct? Of course, yeah, we need to correct this one. It was supposed to be because when you find the derivative here, that will be minus 2, and then minus 1 there, that will make this one exponent 1. Good. That is why now you have minus 2x plus 2 is equals to 10. And then from there, you have the linear equation. You just solve the equation. Unknown one side, minus 2x is equals to 10 minus 2. 10 minus 2 is 8. And now from here is a minus 2x. And what do you do now? Divide by minus 2, divide by minus 2. And therefore, now I can say x is equals to a negative 4. Right? It means the value of x there will be what? Will be a negative 4. Boys and girls, you can check this one. If the value of x is a minus 4, you can just substitute it in there to see g prime of minus 4 there. It's a minus 2 times minus 4, and then plus 2. That will be positive 8 plus 2. Then is 10. Then here you have 10. Now you can see that this value here is x is equals to minus 4. And you are 100%, correct. Good. I think, boys and girls, I have answered your questions very well. Please make sure that you understand, like we said earlier on, when you talk of the gradient, we are referring to the derivative. If you can keep that one in mind, it's very, very important. Very important. Right. Boys and girls, like I said now, we need to look at the point of inflection. We need to look at the point of inflections of the function. Of course, now we are happy. Now we understand the first 3 steps, which are very, very crucial, boys and girls, before you can sketch the functions. Now, can we now determine what? Can we now determine the point of inflections, right? the point of inflections, of course, that will be the last question here. Determine the point of inflections of f. Right, that is a 2 marks question, right? No, 4 marks question, but I will give you 3 minutes to go through that one. Then after that, we will discuss the question with you. Right, thank you, boys and girls. Thank you very much. Let us now look at the last question that we asked here to determine the point of inflection here. Remember, like I said, this question they can ask you in 2 ways. The x value at the point of inflection, and the other one they can see you ask you to determine the coordinates of the point of inflections. Now, when they ask you to determine the coordinates of the point of inflection, then it means you need to have the x as well as the y. Right? You remember now we have plus or minus 2 or 3 ways of determining this one here. But of course, I will use the one you remember where you must find the second derivative. Of course, when you find the second derivative, then we take this one from the first derivative here. We are going to have what? 6x plus what? 6x plus 2. And then the other thing which is very important is you must let this to be 0. We have 6x plus 2 there is equals to 0, which is good. And then 6x is equals to minus 2. Divide by 6, divide by 6. Therefore, x is equals to a third. 1 divided by 3. That will be the x value at the point of inflections. Of course, it will be somewhere here on this side. Is that correct? Yeah, it will be somewhere here on this side. Right. How do you determine the corresponding y value? Of course, you know that just take this one and then substitute it where? You substitute it there in the original equation. I can just do it quickly here with the calculator. Of course, that will be a negative 1 divided by 3, or to the exponent of 3. And then from this one, we have plus. And then here we have 1 divided by 3. No, it should be negative. And then, of course, to the exponent of squared, and then minus 5, and then we have 1 divided by 3, negative 1 there, negative 1, and then we also have positive 3. Right, of course, you see that the corresponding y value, of course, will be a positive 128 divided by 27, which in decimal will be 4,7. Which will be 4,7. You can see clearly there, that is 4,7. But what is important, remember you substitute this in the original functions. Right. Of course, boys and girls, here there is another question. Like I said earlier on, remember at the beginning, how do we determine whether a cubic function is a negative or positive without having the equation? Right. Of course, first of all, if you don't have the equation, of course, but you will have the graph, right? I think you will have the graph. If the equation is not there, you will have the graph. Of course, on that graph, we can ask you to determine the equation thereafter. Right? Like I said, now, to determine if the function is negative or positive, you just look at the graph, right? Now, we said if it's positive, then the graph increases first. It means you are going to have the maximum turning points. Is that correct? Immediately when you have a maximum turning point, then it means the graph is positive. Is that correct? Now, if you have a minimum, if you start with the minimum turning points, then your graph is negative. Then, how do we determine this one? Remember, each and every time when you read the graph, we start from the left. You start from the negative side to the positive one. Now, immediately when you start from the left, now the first turning points that you come across there, if it's the maximum, then your graph is positive. But if it's the minimum, then your graph is negative. The graph decreases first. If the graph decreases first, is a what? Is a negative 1, and then if it's increased first, then A then of course will be positive. Right. I think boys and girls have responded to your questions very well. It's very important if the equation is not there, but the graph will be there. Just look at the graph. Maximum turning points first, the graph is positive. Minimum turning points first, the graph is negative, right? Boys and girls, remember, like I said earlier on, for all these functions, different types of questions that they can ask you under the functions is you must be able to sketch the functions, which of course is very important. The second one, you must be able to determine the equation of the functions, which of course is very, very important. Boys and girls, of course, I wanted us to look at that one, but we'll look at it later on when you determine the equation of the cubic function. But of course, if you understand how to sketch the cubic functions, then of course you will be able to determine what? You'll be able to determine the equation of of cubic functions. Boys and girls, I hope you've enjoyed the lesson, of course, which was very interesting. I've enjoyed those questions that we've asked. Boys and girls, at the end of the day, they are going to help you. Please make sure that each and every day you practice mathematics. That's the only one way that will make sure that you do well here in mathematics, right? Of course, we'll meet again, boys and girls. Keep on practicing cubic functions as well as other functions as well. Thank you very much.